So as the title says, we're looking at JavaEE deployment model, and is it out of date? We're going to be looking at the benefits of using thin wars of fat jars, security benefits of patch runtimes, advantages of building container images to build applications, not infrastructure messaging. And really going through that concept where there's other options out there that's led to the perception that it's out of date. And I think Steve's going to disagree with that. So thank you very much. Steve, whenever you're ready.
Okay, thanks everyone for coming to the webinar. As Jaden said, we'll be looking at this webinar around the JavaEE deployment model, how that works, what its advantages are, disadvantages. We're also splitting the webinar in two halves, really. So we'll address this question in the first half of the webinar, and then the second half, I'll go through some of the original questions that we had in the series and just sort of recap on there to come to a conclusion. So as Jaden said, this is part of a series. This is our 6th webinar. We've been looking at some of the myths or some of the accusations that get thrown at JavaEE, Jakarta EE as a standard, also as a runtime, and whether these things are true in 2021. So today we're looking at, is a JavaEE deployment model out of date? And we'll basically take a look at that and then I'll recap the other questions. So let's start with, what is in a JavaEE application? So in JavaEE, Jakarta EE, what you tend to do is you tend to build your application separately from your application runtime, which we'll come to. And your application will typically have in it your application code, so your classes. It will have other third-party dependencies that are specific to your application, and you may have deployment descriptors, especially if you've got an older application that you're moving, but you don't need to have these, probably since the JavaEE 5 type times, and definitely not in JavaEE 8 and Jakarta EE 9. You don't really necessarily need deployment descriptors. A lot of the work can be done with annotations. So, and then you would package all that up into a single archive. That would either be an EA file if it was more complicated. So an EA file would look like this, but it would also then be nested. So you could potentially have a WAR file and other jar files within it that are your application code. Or more and more people are just packaging their application into a single WAR, because coming down in later versions of JavaEE, you could package services like EGBs and things within a single WAR file. You can even deploy data sources from a WAR file nowadays. So you package that application into a single archive, and then from a developer perspective, largely you'd be done from putting your code together with the dependencies your code needs explicitly and your deployment descriptors. You wouldn't typically have in it any sort of jars from the Jakarta EE APIs. So with this deployment model, you just basically build that archive. What you wouldn't have in your application, so what isn't in your application, if you're doing a JavaEE, Jakarta EE application, is all things that aren't really related to your application. For example, you wouldn't have typically code to do connection pooling or code to write data sources. You may have a driver in there if you decide to package it with your application, which you can on Payara, but you wouldn't have like different old third-party connection pooling code. You wouldn't have necessarily different messaging code in there. You would use JMS or connectors. You wouldn't need to write code for or bring in third-party code for creating metrics or network code or or embed a web server or any of those things in your application, because you just concentrate on building your application, not building infrastructure, and not pushing together your own sort of kit of parts to create your runtime. Because within Jakarta EE, all that would be provided for something by Payara. You would just take your application, as we said, package it up with your business logic, reference the Jakarta EE MicroProfile APIs, as you can see in the orange there, and then the application server itself, or the Jakarta EE runtime, will provide a whole bunch of services to your application. And that would typically make your application quite small. So there's different sort of runtime models that you can build, and these both apply to Jakarta EE and into other FatJar type frameworks, for example, Spring Boot or something like that. So typically in Jakarta EE, you would take that application, you would package it into what we call a thin Mour. It'd be called a thin Mour because, as I said earlier, it would only have in it application code, third-party dependencies of your application code. And then you can take that and then you can deploy it to some runtime somewhere. And as I said on the previous slide, that runtime will provide a whole load of services for you and for your application, and you don't have to package them up with your application. So it tends to be a thin Mour because that may only be a few kilobytes in size. The alternative model is that you would package all this up together into a single archive. And with some frameworks, you would then choose, you would have to assemble, which data source technology you wanted to use, potentially which connection pooling you wanted to use, how you wanted to do metrics, how you wanted to do messaging and configuration, external configuration and security and things like that. You would pull those together and you'd assemble the runtime alongside your application and then package it up into a single archive. And then you would take that archive and you would deploy it into your compute infrastructure, either just run it on the command line with a Java -jar, or you would potentially package it into a container, as we'll see later. And this means that you basically have everything in one archive. So hence it gets called a FatJar because it tends to have a lot of code inside it, code that's unrelated to your application. And it can be tens of megabytes in size, as opposed to a thin Mour, which may be a few kilobytes up to a few megabytes. So that's one of the main differences really between the Jakarta EE deployment model, is that you build your application separately from your runtime, and you ship it you can ship it separately, as opposed to a FatJar where you assemble your runtime from a menu of parts, really. And this has some advantages and disadvantages. Jakarta EE supports, actually, in the Payara product set, we have something called Payara Micro, and it supports actually bundling your micro container, so the bottom half of this left-hand side of the slide, with your application into a single jar, if that's how you'd want to package it. But it also supports actually running and deploying your application separately to the runtime. And one of the big advantages of the Jakarta EE model is you have to look at versioning. And okay, as a developer, it might seem quite easy to take your application components, take your runtime, assemble it all into how exactly you want to craft it, and then put that into a single archive, and then run that on your compute infrastructure. The problem, or one of the disadvantages of doing that, comes when you're down the line, really, and you've had this application or this microservice or whatever it is in production, and you need to understand what you have. So, for example, if there was a critical CVE on a component that is running in your FatJar, who knows what is in that FatJar, and who knows whether that CVE has been fixed, and whether that service that is a single jar file has that component within it. So if you break down the model into 3 layers, then you have different versioning. You can more easily have different versioning. Not saying you can't have it in a FatJar, but it's more visible within the Jakarta EE deployment model. For example, obviously you have a base operating system layer with either you'll have packaged into your container, as we'll see later, or you'll be running on a VM or a bare metal server. And that typically will be independently versioned and patched from your application. You as a developer often may not have control over what version of the operating system will be running in the data center or on the cloud or whatever. And you would hope that someone else is patching and maintaining that layer of the operating system. Similarly, when you have like a managed runtime, so like Payara Micro or Payara Server or any other Jakarta EE server like WebLogic or WebSphere, then you can have a differently independently versioned and patched runtime as well. So that includes everything that's in there. So that all the security code, the HTTP handling, all the layers that I showed on the previous slide that is delivered for you by your Jakarta EE runtime, that can also be independently versioned and patched. For example, obviously us at Payara, we maintain that runtime. We issue releases of it every month. We monitor for security issues and we issue patches or alerts, or we fix them in next release of the runtime of Payara platform. So then similarly, if someone does come to you and says, oh, in operations says, look, we've seen a critical CVE in the Apache library XYZ, do we have that? Then you can talk to your runtime vendor to make sure that's fixed, and you don't have to trawl through running services and open jar files to decide whether or not you have or you haven't got that available. Similarly, obviously, we as the developer of this runtime support and patch and track and do things in the same way on the operating system as the operating system vendor is going to be doing. And you can have confidence based on backwards compatibility and things that you can just move to the next level of that runtime without any major concerns with some light regression testing. And then your application layer itself, as a developer, you can, or an architect, you can concentrate on what you place into your application and manage the dependencies that you have there. If you've got Jakarta EE from an API, you would typically just have a single Jakarta EE API dependency, and then you can manage your third-party dependencies much more simpler in your build cycle than pulling in half the internet to assemble a runtime. And now your application layer is probably going to change very rapidly and more frequently than, say, the Payara platform, and then definitely more frequently than, say, the operating system base layer. So you've got sort of layers of change, really. And this has splitting the application deployment away from the infrastructure has that great advantage. The other advantage that you get is if you do decide not to sort of run on a VM or bare metal, then you need to package and build a container image, so like a Docker image or some other container technology. And again, these technologies are typically, the way it works when you build your images, they're built up in layers. So when you make a change and you want to deploy this onto the cloud, for example, the technology is clever enough to only push the changes, which layers have changed. So if you can have a stable operating system layer, a stable runtime layer, and then you just more frequently change your thin-WAR application, which may only be a few kilobytes in size, then the updates can be much more quick and there's much data flying around, and development cycle can be faster because your thin layer at the top of your container image will change rapidly, whereas the bigger, more heavy layers below will move much slower and will not require as many updates. Whereas if you package all of it into a single application, which is tens of megabytes in size, then you're going to have to push that for every code change, rather than pushing maybe a change to the WAR file size. So that's another advantage really of splitting out your application deployment away from all the runtime that it needs to run and operate. Another advantage is really looking at how you run your application. If you split your application out away from your actual application runtime, your Jakarta EE server, then Payara as a company, our job is to be able to take that application and run it on lots and lots of different infrastructure for you. So you don't have to assemble something specific to run on Azure or something specific to run on Kubernetes. We should be able to take your WAR file written to Jakarta EE standards and either deploy it onto, for example, Payara Micro could be deployed on an edge device, It should be able to be taken and run into a container from using a Payara Micro or Payara Server container images. Obviously, it supports bare metal virtualized infrastructure, but then similarly, we could, and in the server layer, we can do a lot of work to make sure we support Kubernetes well. And we'll see a little bit about this later when I do a recap of everything we've said over the past few weeks. And right up to where we've got, we're about to launch something called Payara Cloud, which is essentially a PaaS for Jakarta EE applications. So you just take a WAR file, push it to the cloud, and then your application will be running. And again, you don't have to, that just takes that thin WAR, and it uses that concept that you have this separately packaged application from your infrastructure that you're running it on, all the infrastructure services that you need from your application runtime or your framework. So to summarize, why the deployment model of Jakarta EE is good and what the advantages are. So essentially, one of the first things is you don't have to assemble a server. And now I know a lot of technical people like to get involved in picking and choosing components of their servers, or pushing bits out they're not using or something like that to try and make it a little bit smaller or a little bit quicker, or also use something they prefer. But the reality is, most of us are actually except unless you work for Payara, most of us are in the job of building business code for business applications, not assembling sort of runtimes that are a self-consistent and secure piece of technology. As fun as it is, people in Payara do get that fun. That is their job. The other thing is that means also that all the pieces that are in a Payara server work together. They're versioned together, they work together, they've been tested together. You're not picking and choosing it. And I say that we manage the versioning of that runtime. So we manage security lifecycle of it. So if there was any CVEs, then you can come to us to ask if there's a CVE associated with it, if there's a specific patch, or the next version of runtime, which would fix all those problems. So it does increase security, separating the application out. In the same way as, if you're packaging container images with base operating systems, who's patching those operating systems for you, those operating system layers in your container? It's the sort of same problem, and that is a problem that is there and is more difficult to solve for operations people and developers in general. And then out of the box, you might go, oh, Payara or something provides too many services, but again, it means you don't have to self-assemble them. So we provide health, we provide health checks, high availability, tracing, scalability, so basically so that you can focus on building your business application, which is typically what you get paid to do. So Jakarta deployment model, has a lot of advantages, as I've said here. What I'm going to do now is basically go through some of the other myths that we've covered in the previous weeks, and just sort of wrap it all up into, why we think Jakarta EE is the best development model for your applications, and why we think Jakarta EE and especially combined with MicroProfile has a very long life. So I will quickly go through some of the questions that we've also faced on this series, and just wrap those up. So you've got your thin WAR, but one of the myths that we looked at was how heavy is an application server in this day and age. So there's been a lot of there's a lot of memes and a lot of things directed at Java EE saying, oh, it's fat, it's slow, it's heavy. And we had a look at what those actually mean, and obviously came to the conclusion that's not true. So I'm basically just going to go through a couple of summary slides that came from that. The first is we actually compared how a Jakarta EE application would compare to a Spring Boot 2 application as much as we could, because these are obviously slightly different things. So we took the pet store application and we took the pet clinic application, and we sort of compared how packaging these all up into a fat jar in the case of Payara Micro and Spring Boot, and what size were they, what were their memory usage and things like that. And the conclusion is essentially that both runtimes are very small. Spring Boot, the file size varied obviously, because as you said, you can assemble the parts of Spring Boot, because that's what you can do. You can choose whether you want to add health checks or those sort of things, or tracing and things. So depending on what you selected, the file size that we got was between 50 and 80 megabytes. And when in the Payara Micro, when we took the thinwar and added it into a Payara Micro to create a big fat jar, then similarly we were 80 megabytes. So we're at the top end because we ship everything in a single runtime. But that doesn't really make a lot of difference from a resource usage perspective. But obviously from an ease of use, it means you don't need to go around selecting and assembling parts. When applications were running, the heap usage, depending on what you did, so we just hit some of the services using Apache Benchmark, and heap usage is really small on these things. We're in the tens of megabytes. Typically, from what we see in applications, heap usage majority is whatever your working set of your application is, not of the underlying runtimes. Both booted within a few seconds, ranging from 2 to 10, depending on what was there. And similarly, when we hit REST endpoints, both of them were doing 2,000 to 3,000 requests per second. So both runtimes are very small. It's not as if Jakarta EE was hugely greater in size than Spring Boot, which would be probably the benchmark most people would use. So during the webinar, we talked about heap usage. So you can see that this is basically a Eclipse memory analyzer tool, heap dump of a Payara Micro running pet store, and after doing some applications, and you can see that the heap usage is 44 megs, like I said on the previous thing. The vast majority, if you hit it, usage would then be web session usage, so basically application code memory usage. So if you take your thinwar deployment, you should have no concerns of packaging it up into a Jakarta EE application, either deploying to a Jakarta EE application server like Payara server, or packaging up with Payara Micro or deploying to Payara Micro. These are not, you should have no concerns that your application is going to be running on a big, fat, heavy runtime. It's just not true anymore. We've done a lot of work to make these things small, fast, and this is, as someone who concentrates on the runtime, this is part of our remit, is to try and get this as small and as quick as possible. That's what we can concentrate on. So then we looked at, okay, that's fine. So application servers or Jakarta EE runtimes are now comparable to many other Java server-side frameworks, but are they cloud native? So we explored what is cloud native, and there's a bit of a mix between terminology of cloud native equals microservices. So we split that out into two questions. So we looked at cloud native, and we looked at it in the context of, can these things run on the cloud? Does Jakarta EE run on the cloud, essentially? So, and the answer obviously is yes. And if we go back to that slide where I had the spectrum of runtime you could use, that we could take your thinwar and we can run it either on an edge device on a single Payara Micro instance, right up to some big Payara cloud, and in the middle was a traditional application deployment. And in Payara, what we do is make sure that our runtime runs well on different types of cloud infrastructure. So this is one traditional deployment that you could use. So you would obviously run virtual machines on Azure, as an example, which could be running on an Azure scale set, so they can elastically scale up or scale down depending on requests. And then you would run that with a domain admin server and some instances. And we've got technology within Payara that we've built specifically so that if you build that out on Azure, for instance, or AWS or GCP, Google Cloud platform, then we can auto create a data grid. We can auto cluster these things. We use the technology of the cloud that we're running on to make sure that instances can find each other and create high availability clusters. And we also have the concept now of things like auto scale groups, so that if you do, if your infrastructure scales out the number of virtual machines, then we can dynamically and elastically reconfigure and understand what's occurred and make sure your application works. So a lot of work goes in, when you separate that runtime away from the application, into making sure that that cloud native is there and Payara supports a lot of cloud key use cases. One of the key things about cloud is effectively compute on demand, so that you can elastically scale up and down your platform. So this model works on all the major cloud platforms. As I say, out the box, it will automatically scale and cluster. So we are cloud native in that mode. And then there's obviously the another mode is when you take Kubernetes. We looked at Kubernetes and how that's becoming, if you like, the infrastructure de facto standard on cloud for deploying containers. So there's obviously other container services that are proprietary to each cloud vendor, but Kubernetes is starting to become like the standard or de facto standard. And again, if we concentrate on the runtime for your application, then we make sure that we can work on Kubernetes. So you could, for example, take your application WAR file, your Jakarta EE microservice, package it up into a pod definition, which would include an operating system, the JVM, Payara Micro in this case, and then you could scale that out using Kubernetes pod scaler or something like that. And again, we support these technologies. Our job as a runtime framework is to make sure that you can do this. So we have Kubernetes native clustering. We can make these things cluster if that's what you wanted to do. Using service definitions and service names, we can retrieve secrets using config stores that access Kubernetes secrets, so that if you wanted to change, for example, a data source connection, depending on how it was configured in Kubernetes secrets, then again, it's our job as Payara to make sure that runtime supports that Kubernetes. So absolutely, if you were taking your ThinWAR and wanting to deploy it onto a cloud native platform using, say, AKS, then we would absolutely support that. And then finally, one of the ways we are cloud native is we're actually building a complete cloud platform as a service. And what this is really doing is taking that deployment model and abstracting it to the next level. So what we're saying is you don't care what the infrastructure is that you're running on, even whether it's Kubernetes. So you don't care about pod definitions and YAML files and ingress and all these other things that have nothing to do with writing applications. All you want to do is take your application and then run it. And again, so we're building a runtime which is in like a completely cloud native, basically a cloud-based runtime, which you will take your application and deploy it like you would to an application server in the old days, but effectively you're deploying it onto the cloud, and it would manage and create all the provision of the infrastructure, organize the SSL, ingress, sort out the DNS, do provision pods on a Kubernetes service, and deploy all that in a single go. And again, a lot of this is because of the beauty of the Jakarta EE deployment model of separating out your business code from where and how we want to run it, or where and which, or even which vendor you want to run it on, allows us as a vendor of this sort of these runtimes of Jakarta EE runtime to think in new different ways, while still allowing you to think about building your application. So we can absolutely run cloud native your WAR file. And the question really then is, oh, well, microservices is newish architecture. Does Java EE or Jakarta EE support microservices? And this is one of the myths that we looked at as well. And again, I'll recap here. So, I mean, basically, many of the Jakarta EE APIs are the foundational APIs for microservice frameworks. REST is, and Jakarta REST in particular, is a foundational API for things like Drop Wizard and which ship Jersey. So original microservice APIs are Jakarta EE APIs. So we have REST as a standard API, and obviously any one of our runtimes will support Jakarta REST. People are using JPA, whether they call it using Hibernate or whether they're actually using JPA directly. The JPA is a foundational Jakarta EE API. Any messaging can come through JMS or connectors, and we, in Payara, we have connectors to many different messaging systems. And then obviously JSON is a big thing for microservice architectures, streaming JSON back and forwards to the browser. JSON APIs are standard foundational Jakarta EE APIs. So Jakarta EE, from an application developer point of view, can absolutely support microservices applications. And then if you combine Jakarta EE with MicroProfile, which again is a similar body developing APIs in the Eclipse Foundation, so sort of sister or brother organization to Jakarta EE with many of the same people and many of the same vendors, then that is extending those core Jakarta EE APIs like Jakarta REST and adding a whole load of very specific microservices arranged APIs. For example, Open API, which will define and give a representation of any of your REST services. We have type-safe REST client. We have a config for building external config in a 12-factor app. Health checking, so that things like Kubernetes and things can actually check whether your application's up, and metrics so we can retrieve and do monitoring. And those old APIs, because, as I say, because of the Jakarta deployment model, they're just shipped as standard with all the Payara platform. So you would again just ship your application and you could get metrics, Open API support, health checking for Kubernetes, and all these things just straight out the box, purely by using Jakarta EE and MicroProfile. And then finally, we looked at a couple of things which are important going forward. So assuming that if you build JavaEE applications or Jakarta EE applications, you can take a thin Mour and you can deploy it anywhere. You can build microservices applications, and you can also run it on any cloud platforms. Do these applications and APIs have any future? So we investigated this in our series through two basically questions. One is, do standards matter? Where we looked at the standards process. And finally, actually right at the beginning, we looked at, is JavaEE outdated and dead? So I'll just summarize that really. JavaEE's been around a long time. It's been around since December 1999. And Jakarta 9.1 was released in May 2021. So we're talking 22 years. And this is why it collects a lot of these myths that, it's old, it requires a whole bunch of XML, which it hasn't for 15, 16 years. But it acquires all these layers of mythology around it, that it's old because it's not been around since 1999. But the reality is that it's evolved and changed drastically through all that time, while at the same time providing stability and longevity for people who do target it as a runtime. So people can take actually old applications and deploy them on new runtimes. So we, in Payara, for example, get quite a lot of applications that may be 6, 7, 10 years old, and what they're doing is they want to run on a modern runtime that, one, is secure and patched compared to where the runtime was 10 years ago, and two, that it supports cloud and then it can run on Kubernetes and all those things. And because of the separation of their application from the runtime, they're not having to go in and try and change internally to their application all their dependencies to make them secure for a start, just fix the CVEs, and then to try and work out how they're going to get this running on Kubernetes. They can actually take their old EA file or WAR file and deploy it on brand new Payara 5 without any change or with minimal change. So this is why one of the reasons that Jakarta EE gets a lot of mythology is that it's been around a long time, which is a good thing, not a bad thing. But it's moving all the time, and it has been updating a lot. JavaEE, as he said, is also foundational technology. Technologies that often beat up on JavaEE are actually intricately dependent on it. So, if you take Tomcat, which is probably the most popular application server, if you want to call it that, in the world, obviously it's a servlet technology. Servlet is a Jakarta EE API, so it is fundamentally dependent on it. Drop Wizard, which came along early in the microservices, obviously uses huge numbers of Jakarta APIs and runs essentially on Jersey and things, which is a implementation of Jakarta REST or JAX-RS. And even the latest, Micronaut or Quarkus, they have dependencies on Jakarta API. So Jakarta is not going away. It's been around for a long time, and the latest, runtimes are actually intricately embedded with it, including Spring. I mean, Spring uses large numbers of individual Jakarta EE APIs and depends on them for its technology. So, and this technology moved to the Eclipse Foundation in over a couple of years, and I won't go too much into that from a time basis, but essentially now, rather than being a technology controlled by a single vendor, it's now in a multi-vendor or multi-member organization at the Eclipse Foundation, which has a good reputation for neutrality and to manage open source development. And everything that we're doing now is open source in Jakarta EE, so anybody can contribute. It's not all behind closed doors. It's all done through open source rules and the Eclipse the Eclipse development process and the Eclipse specification process. So we have governance, we have openness, and we have evolution. And finally, this is all moving on. So Jakarta EE is definitely has a big future, and the next future is version 10. And version 10 will be coming sometime late this year, or maybe next year, early next year. Again, it depends on how people develop the APIs and how they push those forward. And new things will be happening. So these are some of the things that may or may not happen. Again, it's open up to the community to get involved and drive these forward. So we'll be looking at a core profile, which will strip down the definition of the runtime again, mainly probably targeting microservices type models. So you could possibly kick out some of the more display technologies like servlet and things from the core profile, because you're not displaying, you're just creating RESTful web endpoints. There's big work on JAX-RS. One of the things we explored in the webinar in the standards bit is why we have a TCK, which is a technology compatibility kit. And again, that is will be all open source, so that anybody can create a new Jakarta EE runtime and certify it. And there'll be new APIs, new improvements, and obviously support for the latest JDK 17 when it goes LTS. So to wrap up, we looked at 6 questions, and let's answer them one by one. So first one, is Java EE outdated and dead? Absolutely not. No, it's developing in the Eclipse Foundation. 10 will be along very soon, and it's a foundation for many other frameworks. Are application servers heavy? No, they may have been, sometime in the middle of that evolution, but that has changed a lot. We work very hard to make our application runtimes super small, super fast. Is it cloud native? Absolutely. You can run on any cloud platform. You can take an application, take advantage of using Payara platform and run it on AWS or Azure or GCP, and we build within the runtime support that we think is needed for those platforms. Can we do microservices? Absolutely. With MicroProfile, which is a brother or sister operation standards body, then we're actually building specific microservice use cases. But the foundational APIs of most microservices and service like Java are actually Jakarta APIs. And then, do standards matter? I believe they do. Standards basically enable you to create your application to a set of APIs and then choose which runtime. In Payara, you can choose Payara Micro, Payara Platform, Payara Server, or in the future Payara Cloud. But also you could decide to not choose Payara at all. You could decide to use Wildfly or JBoss. So you have an open source or a commercial option. You could choose Apache Tommy from Apache, which will be completely open source, or you could choose something like WebLogic if you had compliance or something, or you wanted to run on an Oracle Cloud or something like that. So standards give you choice, and standards also give you certainty that these things are going to continue, because if one vendor gets bored, then other people will pick it up within the Eclipse Foundation. And finally, it might seem the smallest one, but is the JavaEE deployment model out of date? But I actually think the JavaEE deployment model was invented, 20 odd years ago and was a stroke of genius. That's because what that does is it separates out your application from all the rest of Jakarta EE, which means that innovation can occur outside of your application by people like Payara, and can make sure that you can take that application and 10 years from now, you can run it probably on whatever technology is around later, whatever Java version is about, and get it all patched up to the very latest infrastructure without you having to do too much work as a developer. So hopefully this series has sort of bust some of the myths of Jakarta EE. And if you're a Jakarta EE developer, hopefully it gives you confidence that you're doing the right thing. You're probably on the best community. Or if you're people who are thinking to coming back to Jakarta EE, having looked at other things, that it gives you confidence that it's not a backward step, it's an absolute forward-looking step. So thank you. If you want to try Payara, you can obviously get it on our website. And if you want, from a community perspective, if you want us to help spread the word about Jakarta EE or open source or MicroProfile, then we're here to do that. And we can, Jaden may say a little bit more about that. Okay, any questions, Jaden?
Yes, we have two currently. Anonymous attendee asks, can Payara run microservices based on MicroProfile reactive messaging? I found OpenLiberty and Wildfly able to do so at the moment, but use small RAI implementation. Okay,
at the moment, no, because MicroProfile reactive messaging isn't one of the core platform MicroProfile APIs. It's one of the separate ones. And Payara have chosen to basically choose the core APIs. So if it moves into the core platform for MicroProfile, then we'll absolutely will support it. You can obviously build microservices using other messaging in Payara platform, but not using that API specifically.
Okay, brilliant. And then Anbu Sampath, he asks, what does JCA do? Where can I read about it more?
JCA, okay. JCA is it stands for, well, now it stands for Jakarta Connector. It's called Jakarta Connectors during the transition, but Java Connector Architecture. It's basically an API standard that other people would use. It's not really a developer API to build connectors to different technologies. So, and in a standard way, and then run them on a Jakarta EE runtime. So, to make that more concrete, we have JCA connectors for Apache Kafka. So obviously there's no API standard for Apache Kafka in Jakarta EE. So what we did is we built a JCA connector for Apache Kafka. And practically what that means to you as a developer, what it means is that you can create message-driven beans that receive messages from Apache Kafka, because the JCA architecture allows us to build that connector and run it on multiple different runtimes. And you just deploy it like you would an application. Similarly, we built them for Amazon Q Service and the Azure equivalent, whose name escapes me. Azure Service Bus, I think.
Brilliant. Any other questions?
I'll just quick jump in. To find out more about it, you can go to jakarta.ee, which is the main website for Jakarta initiative, and from there you'll be able to find the specification or find the project, and actually that's how you can find and read more about it.
Awesome. As well, guys, I've just linked below our YouTube channel where we'll be putting these videos, and there's a lot of other content there as well. And I've also linked our meetup group as well, where we'll be putting all our future events. As Steve was talking about earlier with Payara Reef, that's an initiative where we're sort of just opening ourselves to the community. So if there's activities where we could help you guys out, whether that's with experience or sponsorship or collaborations, then we're really open to doing that. So you can, if you head to that page that's linked there, you'll have some more information. And if you get in touch, then you'll probably be speaking to me and we can see how we can help each other out. If there's any other questions that you think of later, then please just send us an email or get in touch on social media, and we'll get back to you. Brilliant. Thank you very much, everyone.
Thanks.
Cheers. Thank you, Mark. It's been really enjoyable. It's been 6 weeks, and we've covered an awful lot. But please do let us know about feedback as well, guys. If this is a format you'd like us to repeat, if there's other subjects or topic areas that you think would work well, then that might be something we could look at. Brilliant. Thank you very much, everyone.
Thanks.
I'll see you again. Bye.
Bye.